and Joe. These two people are dating. This is a little hussy that lives downstairs. This hussy don't creep in on your man. You get rid of the hussy. Okay? No creeping. Get rid of them. How do you get rid of a divided by 2? Multiply by 2. So the first thing we do is we are going to multiply both sides by 2. Hussy gone. Now it's just me and my boyfriend. What does that give me on that side, somebody? 10, 1, 12, 13, 53. 53? Now that the hussy's gone and it's just me and him, I can get rid of him. So what do I need to do? I need to subtract 21, subtract 21. So x is going to be 32. Now some of y'all just said, let me plug in a number, add 21, divided by 2, see if it equals that. Nope, too small. Let me go bigger. Nope, let me go bigger. Let me go smaller. So now we're saying, and if we can double check, 21 plus 32 divided by 2 has to equal 26.5. So 21 plus 32 divided by 2 is going to give me my 26.5. Now, some of you started out by putting in those 5 pieces of data and trying to do 1 bar stats. You can't do it without the missing piece of data. Now, some of you tried to put in the missing piece of data and do 1 bar stats until you got the right answer. I mean, whatever works. Are we good with that one? Now, I always make it look easier than what it is when you're doing it by yourself. All right, let's look at some mode problems. What's the mode of the first one? 1. Because 1 appears more than anything else. What's the mode of the second one? 1 and 2. Because 1 appears twice and 2 appears twice. What's the mode of the next one? Just 1. And I want you to realize that just because a number appears more than once does not make it a mode. It has to appear the most. So because these equally appeared the most, that's why they were a mode. It's not because it appears more than once makes it a mode. It has to appear the most. What's the mode in that one? No mode. All right, let's see what I got down here. All right, this picture is showing you if it is symmetric, the mean, the median, and the mode are the same. So the average of the class, the median of the class, and the mode of the class are all in the hump if it's symmetric. Okay? Now, if it's right skewed or left skewed, your mode is always going to be in the hump. Your mode, oops, didn't mean to mark it out. Your mode is in the hump. Your mode is in the hump. Your mode is in the hump. Because, y'all, what does mode mean? The most. And the hump represents the frequency. Like if we were doing the histogram, the frequency is the height of the bar. So the mode is the biggest bar. So your mode is going to be the most or the biggest bar. So your mode is always going to be where the biggest hump is. Does that make sense? Now, if it's symmetric, your mean, median, and mode are all going to be right there together, localized. Now, if you're taking a test and one person makes really, really good, like everybody fails the test, and you have that one person make really, really good, that one person's grade is going to bring up the average of the class. So if everybody's making in the 20s and one person makes 100, do you agree that's going to bring up the average of the class? Just like here, everybody was making hundreds and 95s and 98s, and somebody makes a 0, what does that do to the average of the class? It brings it down. So, if you are left skewed, that means your average is going to go to the left. If you are right skewed, that means your average is going to go to the right. Now, the median scoots over just a little bit, but the mean is going to go, the average is going to go to wherever your outlier is, to wherever the skewness is. Mode's always going to be in the middle, but the mean is going to go to wherever your skewness is. That person, that outlier, that one person is going to ruin the whole average, ruin that curve, ruin that grade. All right. Yeah, I can do it. Let me put it back on this one because I don't have as much on this one. The main thing they want you to realize, and they usually don't talk about the median as much, they talk about, the mode as much, they talk about the mean. For this one, they like to say the mean equals the median. For this one, they say the mean is, what am I doing, right skewed? The mean is greater than the median. And for this one, they say the mean is less than the median. So, when it's symmetric, your mean and your median are the same thing. Because your mode is not going to change. So we don't even look at the mode. We compare the mean and the median. So the mean and the median are the same thing when it's symmetric. Here, your mean is to the right or greater than your median. Here, your mean is to the left of your median because it's going towards the left, so it's less than. Now, they want us to use this on these next pictures, and the next pictures have a little more going on, so I wanted to. So, for this first one, what kind of skewness is it? Okay. So, we have right skewed. So, tell me about the mean and the median. The mean would be greater than the median. Because remember, the mean is going to be pushed this way. And the median is going to be closer to the mean. Closer to the home. So the mean is going to be greater. It's going to be higher. Tell me about the next one. That one's going to be symmetric. Tell me about the mean and the median. They're going to be equal. Tell me about the next one.
The mean will be less than the median.
So here the mean is going to be that way, and the median is going to be closer to the home. So the mean is going to be less than the median. So, have it down here. And they're saying that these were samples, so that's why I used the X bar. So the mean is greater than the median because it's skewed right. The mean is equal to the median because it's bell-shaped or normal. And the mean is less than the median because it's skewed left. Now, it says which measure, mean or median, best describes the center of the measures of center. So, the mean, the median, or the mode. The mode is not going to describe it because the mode's always in the middle. So, we want to know, does the mean or the median best describe? Well, if they're equal, which is what kind of distribution? If they're equal, what kind is it? What does it look like? Bell-shaped. So, if they're equal, the mean best describes it. But if they're not equal, which means it's going to be skewed, the median best describes it. So, if somebody says, what's going to best describe y'all's grades? The mean, the median, or the mode? Well, if your class is bell-shaped, the mean best describes your grades. But if your class is skewed, the median best describes your grades. So when we give y'all the average may not best describe your grades sometimes. It's according to whether your grades are bell-shaped or not. So if your grades are bell-shaped, then the mean is going to best describe it. If your grades are skewed, then the median is going to best describe your grades. The mode is always in the hump, so the mode doesn't matter. So the mean best describes your grades if it is bell-shaped. The median best describes your grades if it is skewed. So if it's bell-shaped or if it's skewed. So it's according to what the distribution looks like as to what best describes the data. All right, one more page of these notes. We've put in data and we've done the mean, median, and mode. We're now going to put in data and graph a histogram. Y'all ready? All right, let's look at this data. We got this. Go to Stat Edit, just like we were doing before. Stat Edit. We're going to do a histogram. Stat Edit, go to the top, clear your data, and we're going to type in data. I don't care if you type in data this way or if you type in data this way, as long as all your data is there. There should be 25 pieces of data. So when you finish entering, you should be on line number 26. I went up and down. You can go side to side. It does not matter. You just got to make sure your data is correct. Mine's probably not. Let me double check it. And if you miss a piece of data, you can type over it. You can delete it. So, there's 25 pieces of data, it's 5 by 5, so 25 pieces of data, so when I finish, I am on line number 26. That kind of tells me that I have the right pieces of data, the right number of pieces of data. So I'm going to pull that over so that you can kind of see what I did. I did stat, edit, and I typed in all the data. Now, I'm not going to do calculate one of our stats because that just tells me the mean and the median. I'm not going to do that. So I'm going to do something a little bit different. Okay? And I have the directions up here, so if you need to come back to it. We entered the data into L1. So this is what I'm going to do, and in parentheses is how we're going to do it. So we're going to go to second y equals. So here's my y equals second y equals means that we're getting to the blue stuff on the top of the y equals button. So we're going to go to stat plot, which is above the y equals. So we're going to do second and the y equals button. I did second and the y equals button, so I'm really doing stat plot. Okay? Now, I want to hit enter because I want to go to plot 1. So I did second plot 1. Now, you want your plot 1 to be on. So right now mine is off because off is black. So I get on top of the word on and I hit enter. Then I come down and over until I get on top of the histogram. Now, if yours does not say L1, L1, L2, L3, L1 is right above the 1. If you need it to say L1, you hit second L1 right there where it's supposed to say L1. Let me pull this down so that you can have a visual of what it's supposed to look like. So the main things that you want happen, you want plot 1 to be black, you want on to be black, you want the histogram, and you want this to say L1 and frequency to say 1. Cool? Yes. And if yours doesn't look like that, then call me over and we can fix it. Okay, you are on, that means that it's going to be little dots. You want it to be that one and hit enter. There you go. And so if you have, for example, if you have this one, that means when you graph it, it's going to be a bunch of dots. If you have this one, then it's going to be a line graph. If you have these, then it's going to be a box and whisker. We want it to look like a histogram. That's why we chose that one. So this just tells me what my graph is going to look like. All right. Now, Zoom 9. Ooh, so cute. Zoom 9 means look at me. Okay, zoom is in the middle up underneath your screen. Right here. Zoom 9 means look at me. So we just turned all 25 of those points into a graph. Now, here's the problem though. Sometimes our graph doesn't look like the multiple choice graph in my math lab. So we've got to know how to manipulate our graph. So if I just tell you to draw one, there we have it. Hold on. So let me finish this one though and then we'll talk about it. It says, determine the shape of the distribution. So let's talk about this shape. What would you say about that shape? Is it symmetric? Is it skewed right? Is it skewed left? Raise your hand if you think it's symmetric. Raise your hand if it's skewed right. Raise your hand if it's skewed left. Okay, so we're thinking that it's skewed right. So we're looking at this and we're saying, okay, I think that it's skewed right. Now, I don't have to think anymore. I now can go to one var stats and I can look at my mean and I can look at my median. If my mean and my median are equal, then it's symmetric. If my mean is greater than my median or my mean is less than my median, then I can tell if it's definite skewed right or definite skewed left. So let's go and do one var stats. Our data's already in there. So let's do stat, calculate, one var stats. All right, so there's that one. And then I'm gonna scroll down, and there's that one. So we want to compare our mean, and we want to compare our median. So our mean is 22. Our median is 25. So our mean is less than our median. So if our mode is here, and then that means our median and then our mean, what kind of skewness is it? Can't always go on looks. This one is skewed left based on the mean and the median. What best describes the data? The mean or the median? The who?
Median.
The median. If they were equal, it would be the mean. But because they're not equal, because it's skewed, it's going to be the median. So this one is skewed left. Even though it looks like it's skewed right. We can't go by looks on this one. We've got to go by numbers on this one. All right, let's look. I've got a homework problem to look at, 3.1, number 8. Let me come out here to homework. Homework. 3.1, number 8. Yes. 3.1, number 8. Continue. Number 8. Let's see if I want to do one before I do this. I don't know what this was. Okay, this is a good one. All right. A random sample of 15 college students were asked, how many hours per week typically do you work outside the home? Their responses are shown on the right. Determine the shape of the distribution of hours worked by drawing a frequency histogram and computing the mean and the median. Which measure of central tendency better describes the hours worked? So, here's our data. Let's go into our calculator. Let's do stat edit, type in the data. So stat edit, clear your list, type in the data. There's 2, 4, 5, 10. There's 15 pieces of data. Problem and put it in our notes. That way you will have it to look at as well. I'm not on 3. This one. Page. Paste. Alright, so I'm going to come to my calculator. I'm going to do stat edit. Go to the top, clear enter. All right, 15 pieces of data. I'm on line number 16. Okay, Now, we have already turned our stat plot on, so if I go back up there, it's already on and it's already on histogram. So until you turn it off, it's good. Now, you're gonna have to remember how to do this when you go over to take your test, because you're not gonna be using this calculator. So you're gonna have to remember, oh crap, I've gotta turn my stat plot on to look at a histogram. So our stat plot's already on. So we've got to say, look at me. So what do I do to look at me? It's like love potion number 9. Zoom 9. So if I do zoom 9, I got a little problem. It don't look nothing like any of those. Yes, boo-boo.
My graph don't look like that. Mine didn't look like that.
You have 320 at the top.
Yeah,
Your second number's
you mistyped your name.
Damn it. Hold on. Austin, I'll get to you in a second. The calculator is only as good as the person who uses it. 15,
20 hours to work week.
15, with the rest right, 17, 28, no, 26, 8. Let me do zoom 9 and see if that looks like y'all's now. 9. Does that look like y'all's?
Yeah.
My bad. See, I was displaying what y'all should not do. Just kidding. Isn't that what teachers say? I screwed up. Let's see, Austin, in Austin? You probably mistyped something in. Go back and do what I did. Okay. So, ours does not look like theirs. So we have a little bit of a problem. When you do zoom 9, your calculator chooses how wide it wants to be, what the class widths are, what the frequencies are. So your calculator has free range of what class width and what height and what everything. It may or may not match what my math lab chooses. Okay? So we need to make the class width match what theirs are, and we need to make the frequencies match what theirs are. So here's how we do that. On your calculator, you hit the window button. The window button. Now let me explain about the window button. When you're looking at a graph, your x-axis, the x-min would be the minimum value you want to use on the x-axis. The x-max is going to be the maximum value you want to use on the x-axis. X-scale is what you want to count by. So are you counting by 1s? Are you counting by 2s? Are you counting by 50s? Y-min is going to be the minimum value that you use on the y-axis. Y-max is going to be the maximum value that you're going to use on the y-axis. And y-scale is going to be what you're counting by on the y-axis. And you always want to let your x resolution be 1. So if we look at their little graph, and I'm going to take one of their graphs and I'm going to make it bigger. All of their graphs are the same. Let me go back to my homework. I'm going to grab one graph and I'm going to make it bigger. And we're going to talk about what we want to make our window. So we have to come up with an x-min, an x-max, an x-scale, a y-min, a y-max, and a y-scale. So our x-min would be on the x-axis. What is your smallest number? 0. On the x-axis, what is your largest number?
35.
35. And what are you counting by? 5s. 5, 10, 15, 20. So, on your x-axis, you're going from 0 to 35. and you're counting in increments of 5. Y'all with me? Now, on the y-axis, what is your y minimum? What is your y maximum? And what are you counting by?
1.
You're counting by ones each time. And your y res is always